All right, so we're going to go ahead and get started here. My name is Jonathan Wage. I've been working on the Doctrine project for a little over a decade. I've been using PHP for going on almost 20 years actually now. It's kind of amazing to sit here and think about that and say that. Been using PHP since the very early days, I think towards the end of 3 and the beginning of 4. And so just to give you a little background, to tell you a little bit about what is Doctrine. Doctrine is an open source project, obviously. It started around the year 2006. Initially, the project was only an object relational mapper. It was one project and one library. And over the years, as Doctrine, the ORM improved, and we continued to decouple the individual pieces that made up the ORM, some of those packages became popular outside of the ORM, and they're utilized across other open source projects. For example, the Doctrine annotations project, which is what we use for mapping information in the ORM on doc blocks, that gets utilized in Symfony and several other popular open source projects. So it's evolved very much from one single project to an organization with many open source projects underneath the Doctrine project umbrella. So in this webinar, we're going to introduce you to Doctrine, and we're going to do it within the context of a new Symfony Flex application. You can, of course, use Doctrine with your own homegrown framework, or you can use it with any other framework. You could use it with Laravel, you could use it with Zend. It really doesn't matter. My personal preference is to use Symfony. That's what I use in most of my professional work. So the examples here that I'll show in this webinar are all based around Symfony. So to start off, you can use this handy command to create a brand new project. This has actually changed a little bit since I created this material. The whole Symfony Cloud and the Symfony command line is new, and you can use that to create your projects, but this command will still work as well. So then once you create that project, it basically creates a whole new directory with a blank Symfony application inside of it. So once you go into that application, you can then run other commands to include things, to require things. So Symfony Flex by default doesn't come with anything. It comes with the bare minimum requirements in order to run just a regular application without any fancy functionality or any dependencies to anything else. So the first thing we have to do is require the ORM pack. This is what brings in the base Doctrine functionality that you would want to use to start building an application that requires a database. And in addition to the ORM pack, we're going to install the Maker bundle, and this is useful for generating boilerplate code, and it's useful for demonstration purposes and to kind of make it easy to easily spin up examples, and that'll be really helpful for this webinar. So now that you have Doctrine installed, you'll want to configure the DSN for the connection. And in the root of the project, you'll find a .env file. And inside of that file, you will see an environment variable named database_URL. You'll want to set this to your local MySQL server that's running and set your username and password that you have for your server. Probably it's going to be, a root username with no password if you haven't set one. So Doctrine supports pretty much all of the relational databases that PHP supports. I think all of them. I don't think there is one that Doctrine doesn't support. If you can connect to it with PDO, Doctrine is able to support it. It comes out of the box with all of these relational databases supported. But if you did have, a very specific version of some database, it could be theoretically possible for you to write your own driver. But most people aren't going to need to do things like that, and most people are using something like MySQL or Postgres. So that really shouldn't be something that you have to do, or anyone has to do on a regular basis. If you did want to use a different database type than MySQL, you could change the database URL to configure a path to a SQLite database. And that can be useful for testing if you don't have MySQL. Which really, in my opinion, not a great reason to use SQLite. It's easy to install MySQL, so I would just use MySQL. So then once you have everything configured and you have Doctrine installed, you can run this command to create the database that we configured in that .env file. Once that database is created, then we can start to do things with Doctrine to start to populate our database with details of our application. So in order to start that, we need to actually create some tables inside of that database. And when you installed the ORM pack, it also installed a tool from Doctrine that is the Doctrine Migrations library. And this tool is basically a tool that allows you to version your database and to manage schema changes in PHP code. So the first thing that you'll want to do is generate a blank migration with this command. And what that's going to do is generate a class that looks like this. This class has an up and a down method, and right now they're just blank. But the idea is that whenever you run the migrations, it will execute the up method of any versions in your code base that haven't been executed on the database that you're connected to. So Doctrine actually keeps track of the version numbers and which ones have been executed and which ones have not. So if I were to fill in this migration and say I want to add a table named user with a column named ID as the auto increment primary key and a string column named username, and then in the down method, you basically want to reverse what you did in the up. And what this allows is you can basically revert a migration if you needed to. In production, that's not something that is usually typical. That workflow for reverting migrations can be useful in your development workflow when you're developing this migration and you want to create the table and then drop the table and then add another column and then drop it and wash, rinse, and repeat that process until you get the table looking the way you want it to look for your application. But it's a good idea to always have a down that reverses everything that you do in your up. In addition to that, what I would recommend is running the migration once, and it's going to produce SQL from this code. And what I like to do is copy that SQL and actually put it into the migration. And I like to do this because it makes it much clearer and easier for other developers to look at the migration and review it and understand exactly what SQL is going to be executed no matter which environment the migration gets ran on. So it's just a little bit safer, it's easier to review, and it gives you a little bit more peace of mind to know exactly what SQL is going to be executed instead of relying on this abstraction. So now once you have your migration written, if you run the migrations migrate command, it's going to see that, well, we haven't ran any migrations yet, and we're basically at version 0. And every version migration is time-stamped with a date. So it's able to say, what is the current version that this database that we're connected to is at? and what is the latest version that we have available in the source code. And it is going to go through all of those migrations and execute the up method on each of those migrations, effectively bringing the database up to date with all of the migrations that are defined in your code. So you can see I only have one migration, so only one migration was executed. That migration had one SQL query, and it was to create the user table. And to revert the migration, if you just run the same command and pass an argument, the first argument can either be a version number that you want to migrate to. So in this case, we're going to use an alias named prev, which basically just migrates to the previous migration. And since we only have one migration, it basically reverts down to 0 from the migration that we're currently at. And since we're executing down instead of migrating up, it's going to execute the down method, which drops the user table. So now we'll rerun that migration just like we did here, and it'll recreate the table. So now we have this table created in our application, and we want to start using that table to write data to and to read that data back from. So if you remember at the beginning of the webinar, we installed the maker bundle, and the maker bundle comes with a command called make:controller, and this is a part of the Symfony Flex ecosystem, and it allows you to generate a new blank controller. Just like we generated a blank migration, we're able to generate this controller to then start writing our code in. So then, once you have generated that controller, it's going to look like the following. It generates it at a route named /users. It names the route users, and by default, it just returns some standard JSON to the browser. And we're actually going to, in these examples, use this controller from the command line, so you'll see the JSON that gets returned. So we're going to modify that controller, and we're going to use Symfony's dependency injection to inject the connection service into our create action. And this create action is going to use the connection to insert a record into the user table where the value of the username column comes from a request post parameter named username. And then we're going to return JSON with success equals true and a message that says created the username successfully. So now let's look at what that looks like when we actually execute that action from the command line with curl. You'll see that I execute the user's create path with a post parameter named username with a value of John, and the message that I get back is created John successfully. So I'll go ahead and create another user too, a user with a username Ryan. So now we have 2 users in our database. And then the next thing that we'll do is create another action in the same controller that will basically list the users that exist in the database. And again, we're going to inject the connection service into the users action. And then we're going to use that connection to execute a query that will select all of the data from the user table. Now, keep in mind, this is just an example. You know, in a normal real-world application, you wouldn't select star and pass all of that data to JSON. In a real-world application, you would potentially have tens of thousands or hundreds or millions of users. So this isn't a real use case. It's just to demonstrate how the API of Doctrine works and how you can execute queries. So now if I run that action with curl, I'm going to get JSON back for those 2 users that I created with the previous curl command. So you'll see that I have ID 1 and 2 and username John and Ryan. So what if you want an action that reads an individual user record from the database? That's easily possible. So you can create another action named user, singular, and we're gonna inject the same connection instance, and we're also gonna accept a parameter on the user action of a string named username. And you'll see in the route definition, we define a parameter for the route named username. So when you execute this URL and you put in a username here, the value that's in the route parameter named username gets passed to the user action named username. And then we can take that string username and plug it into a query to give me basically one record where username equals the past username. So there's actually a major problem right here with this code. There's a SQL injection. If someone were to manipulate this string username and put some SQL in it, they could actually execute arbitrary SQL on this query right here. So you never want to string concatenate or embed user inputted data into SQL queries. You always want to use parameter placeholders. So instead of concatenating the value username that the user passes in the URL directly into the SQL query, you're going to put this placeholder here, and the syntax with the colon and the name of the placeholder is how you define one of those placeholders. And then the second argument to the fetch all method is an array of the values that line up with the parameters that you have defined in the query. So this makes sure that the username value is escaped properly, and it is impossible for any user to do something malicious and execute arbitrary SQL against our database from the outside. All right, so now we have this action done, and when you execute that action, it would basically just return one of these rows, one of these objects instead of multiple. So now we've used just the raw database connection to insert some data, and we use the migrations to create the table. We use the connection to read the data back and to spit that array of data back to the curl command as JSON. So now what if you want to actually start using the ORM on top of the database abstraction layer instead of working directly with the rows of the arrays of data stored in the database? So again, we'll use the maker bundle to generate an entity named user. And this command will generate a class in the source folder, the source entity folder, in a file named user.php. And it will also generate a blank repository for the user entity. So this is what the user entity looks like. It will generate the ID and the username that we've defined in our database. You can see these annotations that I mentioned earlier. That is handled by the Doctrine annotations library. And all this really does is it tells Doctrine internally how to handle the values in these properties. So we have to be able to convert the data back and forth between how it's stored in the database and how it's stored as a PHP property or variable within PHP. So when you query data back from the database abstraction layer, you're really just getting back all strings. But we want to make sure that the values get typed properly in Doctrine when we put those values into the properties on the class. So that's why we type this as an integer and we type this as a string, and we tell it that the length is 255. These are all the things that Doctrine needs to know in order to be able to persist and read this data back from the database correctly. So once you have your entity, the main service that you use to interact with those entities is the entity manager. The entity manager is very similar to the connection object that we injected before. It's just instead of dealing with rows in a table and columns in a table, you're dealing with objects and properties of that object. So you're no longer dealing directly with the database. You're dealing with an abstraction layer that sits in between your application code and the database. So a user row in the database is now represented as a user entity, and we can create a new user object, set the username with the same request parameter that we did previously when we were working directly with Doctrine, the Doctrine database abstraction layer. And then we create that user, we call persist, and what the persist method does is it tells Doctrine that I have this new entity that I want you to manage the state of. And now that Doctrine knows about this object, it says, I've never seen this object before, it must be new, so let's basically schedule it to be inserted. And then when you call flush, Doctrine internally looks at all of the objects and entities, the entities that it knows about, and it analyzes them. And it says, this is an object that I knew about before. Let's see if there are any properties that have values that have changed since I was first introduced to this object. And then flush just computes all of those changes and writes them to the database with insert SQL statements and update and delete statements to synchronize the state of all of the objects that you have in PHP's memory with the state of the database in MySQL or SQLite or Postgres. And the Doctrine ORM will execute platform-specific SQL to persist all of that data to the database. So you don't have to write manual SQL or do anything specific to make this work. And in theory, this code will work on any relational database. And Doctrine underneath the hood, if you're connected with Postgres or you're connected with MySQL, it will use the appropriate SQL for that relational database that you're connected with. So that may not be too useful in an application because you're not usually switching between databases, but imagine third-party code that you use, say I write a bundle that can be, anyone can use it, and one person might use MySQL and one person might use Postgres. So if your reusable code doesn't ever depend on things that are specific to the relational database, then that code is portable across any relational database. So like I said, that's not really too useful in the context of an application, but for third-party shareable code that may be up on GitHub that's all open source, it's really useful because then your third-party code can be used with any relational database. So I already explained these two methods. This is kind of some pseudocode that represents how flush works internally. So when you call flush, the first thing that it does is it says, give me all of the objects that Doctrine is tracking, and then get the old values and the new values, and then compare those values and produce a change set. And then at the end, we basically have an array of change sets that's literally just an array of all of the entities that Doctrine knows about. And then inside of that array is another array with the old values and the new values. And then that plain old PHP array can then be used to generate the SQL statements that are required in order to persist those changes to the database. So this is not what the code looks like internally in Doctrine. It's literally just pseudocode that demonstrates internally kind of what's happening when you actually call flush. So it's actually beneficial to try to call flush as few times as possible, because Doctrine allows you to basically build up many changes to many objects and insert many objects in memory and then flush them to the database all at once at the very end. So Doctrine can actually, in a very optimized way, insert those records into the database as efficiently as possible. And you can avoid scenarios where you're calling flush many times and making, computing change sets on objects over and over and over again that haven't changed. So it's ideal in the context of a web application or a console command to try and call flush as few times as possible. If you're only inserting or updating a few objects, then you really only need to call flush once. if you are batch updating or batch inserting many objects, then you probably want to call flush every, say, 100 times or every 1,000 times. And then after you call flush, there's another method on the entity manager called clear that basically erases all of the objects from memory so that the entity manager doesn't compute those changes on those objects again when you call flush for the next batch. So the next concept that I will introduce you to is called the entity repositories. And these are basically the layer that your application will interact with to execute queries. You really, in your application code, you don't want to have queries sprinkled out throughout your controllers or throughout your service layer. You really want to have all of your queries isolated into this layer. And then your service layer and your controllers will just call methods on this repository. So here we got that repository generated by default, and it contains this commented out method as an example that you can use to follow. So let's use the user repository and let's rewrite one of those actions that we had before where we were injecting the connection and we were running a SQL query manually to return all of the user data as arrays. And in this case, we're going to inject the user repository instead, and we're going to call the find all method on the repository. And this method, it's not going to return an array of arrays. It's going to return an array of user instances. So I can't convert an object to JSON automatically. So we're going to loop over with an array map call all of the users that were returned by find all and convert each user object into an array that can be JSON encoded. So we effectively made this action behave exactly the same way it did before, except now we're using the ORM and we're working with objects instead of arrays of data. So again, this is a really simple example. It's just one property. But the benefit of doing this is you can have entities that can abstract away logic and other details of the model that really would be hard to do with an array of data. Well, not really hard, it would be impossible to do. So the entities give you a layer where you can encapsulate logic around the data that is contained in the database. So the entity repository also has, it has several methods available that you can use to make very common queries. It uses the __ call method to basically allow you to call any method. And in the first query, find one by username, that's going to literally execute a query that says select star from user where username equals the value that gets passed through this method. And same for the find by field name, except it's going to return multiple user records that match field name equals value. There is also a find by method where you can explicitly pass in the values that you want to search by. And again, these just get translated into SQL queries, and they're portable across any relational database. So if you're writing shareable third-party code that may be used on multiple different relational databases, you definitely want to avoid writing any platform-specific SQL in your code. In addition to find by, there's a find one by, same as the previous method, except it only returns the first object that matches the parameters that are passed to the method. Now, though the magic methods exist, it would be my advice and recommendation to never really use those methods except for when you're quickly prototyping some functionality or testing or debugging something. In the end, when you're done with your application, you should really be using explicitly defined methods in the repository that do very specific things and don't rely on anything magic. So we're going to define a method called find active users. That basically just creates an empty query builder and then adds a where condition that says u.active equals 1. And then we call get query, and that returns a query object, and then we can call the execute method on that query object. And the execute method returns an array, and you can see I have it typed int as an array, returning an array of user objects. So, so what happens later down the road when we added this user entity? It's all great. Our application is out in the wild. It's running in production. And we want to add a new feature to the user to add a property called Twitter that basically stores their Twitter handle. And that column doesn't exist in the database yet. It doesn't exist in our entity either. So if you rerun the make entity command, it will allow you to add new columns to that user entity. So you'll see that now I have this new column called Twitter in our entity. But now we have this column in our entity, but we also need to make sure that it exists in the database. So if you run make migration, it will actually compare the current state of your database schema to the schema that would be produced by all of the entities and the mapping information defined in those annotations. And it's able to see that, okay, I have a user table. It has an ID and a username, but there's this Twitter property that doesn't exist in the table, but does exist on the entity. So then we're able to take that fact that we know that that Twitter property exists, and using Doctrine's ability to generate platform-specific SQL, it can automatically generate that up method with the alter table statement that modifies the user table to add the Twitter column with varchar 255 and a default of null. And you'll notice that I didn't say anything about a varchar here. Doctrine knows internally that the string type in the case of MySQL gets mapped to a varchar type. And on another relational database, it might produce a different SQL depending on the type that it needs to represent the string type in the database. So now that we have this migration created, if you run the command that we ran in the beginning of the webinar, the migrations migrate command, it's going to see that I'm at this current version, which is the version that we migrated to before, and it's going to see that there's this new version that exists that hasn't been migrated. And it's going to execute that up method, and you'll see that it executes that alter table SQL query that was generated for us. So now we have this new property in our user entity. We have the new column in the database, and we want to start utilizing that data when we are updating a user in the update action in the Symfony controller. So you'll see that the route here that's defined has a username parameter, and that's what we're going to use to look up the user that we want to update. And we inject the user repository. That's what we're going to use to find an existing user in the database based on the username that gets passed through the route right here at the end of the update method. And then we also inject the entity manager and the request. And we inject the request because we want to get the username and Twitter handle that we want to update the user record to in the database. And we inject the entity manager because once we call these setters on the user entity, Doctrine internally knows about this user object because I fetched it from Doctrine. And when I call flush, it's going to know that the username property and the Twitter property have changed. And it's going to result in an update statement that changes the username column and the Twitter column to the values that got passed through the request. So now when I run this command from the command line and say, I want to call the user's update path for the username Ryan, and I want to keep the username as Ryan, but I want to set Twitter to Weaver Ryan. So when I execute that, it will update the database. And now let's update the user's action to return the value of the Twitter property with the get Twitter getter method on the user entity. So now when I run this command, you'll see that I get the same data we got back before, but my Twitter handle is null. But the Twitter handle for Ryan is now set to Weaver Ryan because of the update statement that we executed previously. So if you want to update the user method that returns one user object, again, we're using that find one by username method, and we're going to return an array of data to the JSON method that basically returns the username and the Twitter handle. So now when I execute that one action for the user named Ryan, I'm going to get back a JSON object, and you'll see that the Twitter handle is updated based on the request we made previously. So some other features that Doctrine has in the database abstraction layer, and this is really kind of the foundation of the database migrations, and really everything that underpins the ORM, is the ability to inspect the schema of a database and programmatically list all the tables that exist in the database. And then the list tables method that you see here in this method returns an array of table objects. And each table object has an API that lets you inspect information about that table. So you can see here that I list the tables, I loop over all those tables, and I build up an array of data where the key of that array is the name of the table, and then I loop over all of the columns in that table and populate an array called columns with the name of the columns. So if I execute this action, just like we've executed the other actions with curl, you're going to get an output like this. And you'll see that we have a user table with columns ID, username, and Twitter. But you'll also notice this other table that we didn't create explicitly called migration versions. That's the table that the Doctrine migrations library creates for you automatically to track which versions have been migrated. So that's how the utility knows that one version has been executed and another has not. So transactions. Usually when you execute migrations, each migration version is wrapped in one transaction. There's a new feature that was added to Doctrine Migrations 2.0 called All or Nothing. And this is only supported, actually let me step back. So this is an example of just the raw use of a transaction where, say you update a record in the user table and you need all these things to happen at once. And if any of those things fail, you need to revert them all. So in this example, I'm updating the users table and I'm setting the Twitter handle to jwage, where username equals jwage. And I may execute some other methods down below, but say one of them throws an exception and it never gets to this point where I'm calling commit, and it gets caught by this catch. And when I call connection rollback, that effectively never commits this update to the database. And the things that have happened in this try block are either consistently done 100% or none of it happens and everything is rolled back. So it's always really important to think about your use of transactions, and the goal is basically you never want to have inconsistent state in your database where you have a procedure that gets executed and only half of that procedure actually made it to the database. And then you have basically corrupt, broken data in your database that would then need to be manually fixed. So there is actually a method on the connection object called transactional that really mimics exactly what this does, except you can pass in a closure, and anything that happens inside of this closure, if anything inside of here throws an exception, anything that happened before that exception will automatically be rolled back. So this just kind of eliminates some of the boilerplate code that you have here, and you can use these transactional methods to kind of make your application code a little bit cleaner. And the closure, the anonymous function, gets past the connection object so that you can execute queries and do other stuff with that connection object. So we've shown you some very basic methods that you can use to execute queries with Doctrine. There's another more advanced functionality in the Doctrine ORM called the Doctrine query language. And this is a query language that's very similar to SQL, except in SQL, you're thinking in terms of databases, tables, and columns. In DQL, you're thinking in terms of classes and objects and the properties on those objects. And you may have columns in the database with a different name in the database, but it's mapped with a different property name in the class. This can be really useful in legacy applications where maybe you have a not so great naming schema in the database, but you want to create better named properties in the class, in the entity, but have that property in the entity mapped to the old legacy column name in the database. So that way your entities can have new, clean, easy to understand naming, but still utilize a legacy database schema underneath the hood. So when you write a DQL query, that DQL query is being parsed and transformed into a SQL query for the relational database type that you're connected with. So in this example, I'm writing a DQL query, and I'm doing it with the query builder, which is a Fluent interface that allows me to define a query with a programmable Fluent interface. And then that DQL query gets parsed and transformed into a SQL query. And when I execute it, I get an array of user instances back. So this is really the same as that magic method that we were executing before to find one by username or to find by username. But we're doing it much more explicitly instead of relying on any magic. So this is the DQL in the top that what that looks like. And you see how that instead of a table name here, it's the actual namespaced class. And then this is actually the property name. In this example, the status property is also named status in the database, in the column. But this is the SQL that gets generated from that DQL query. So if you don't want to use the query builder, you have the option to just write the DQL yourself. So it feels very similar to just writing SQL, except you're thinking in terms of classes and objects and properties on those objects and not tables and columns on those tables. So this gives me, this is a query that says, give me all of the users where the username property equals the username parameter placeholder, just like we did before. With SQL, you can specify a parameter, and this is to avoid SQL injections, just the same as you would if you were writing SQL. And the execute method accepts the first argument is an array of values that line up where the key matches the name of the placeholder over here, and the value is the value that you actually want to look up in the database for records that match the username of John. So I'll show you a little bit more advanced DQL. These are some features that are built in to the DQL syntax that, you know, would normally be possible with SQL, but the SQL might be really complex, and the DQL can hide a lot of the complexity of, you know, how the entity layer in Doctrine gets converted to how that data is represented in the database. So I may have a user object that has a relationship to another entity named phone number, and a user could have many phone numbers. And if I want to run a query that says, give me all of the users where the user has no phone numbers, you could use the isEmpty syntax, or size of phone numbers is greater than 1. So that'll give me all the users that have at least one phone number. This third one would allow me to say, give me all of the user IDs where the group ID that I pass in the query is one of the user's groups. And then same thing here, this is a subquery where I am selecting user IDs where the user has phone numbers. It's basically kind of the same as one of these, but it's an explicit subquery instead of using one of these built-in features. So Doctrine also has the ability to create these data transfer objects. So say you didn't want to hydrate or build an entire object, and you only want to utilize a couple of properties. DQL has this syntax called new that allows you to say select new and then the name of any PHP object. It doesn't even have to be a Doctrine object. It's literally just a plain old PHP object. And the arguments that you pass to customer DTO here are values from the SQL query, and they get passed through the constructor of the class that you pass to the new argument. So I may join and make a really complex query and combine data from multiple relationships across the database. And then all of those values, see like c.name comes from the customer entity. e.email comes from the email entity. And a.city comes from the address entity. And I want to represent all of that data as a customer DTO. And I inject the name, email, and city into that object and set it to properties on that object. And it's just a plain old PHP object. It doesn't know about Doctrine. It doesn't care about Doctrine. The benefit of these types of things is now I can unit test this customer DTO. I could use it outside of Doctrine if I wanted to. It just makes it a lot easier when your model layer is completely unaware of the persistence layer. It really shouldn't care or even know about Doctrine. Doctrine should just not even be in its mind. It shouldn't even exist as far as it's concerned. So some people don't like to use DQL at all. They actually want to write raw SQL, and then they want to manually map the data that's returned from that SQL to an entity. So in this example, I've written a regular old SQL query, and I'm selecting ID, username, and Twitter from the user table where username equals the username value that I set the parameter value to. And then I use this result set mapping that I pass to the second argument of the create native query method. And this is basically the mapping information that tells Doctrine what to do with these column values that are returned from Doctrine. And I'm basically mapping with these methods that says the U alias in here is the user class, and the U.ID column gets mapped to the ID property in the user class. So I basically have to explicitly tell Doctrine exactly what to do with the columns that come back from this query and where to put them, which properties to put them in the entity. So Doctrine does all this for you automatically. If you use DQL, it is able to combine the mapping information that's defined in those annotations so that it can automatically know that, okay, the ID column from the database goes into the ID property, the username column goes into the username property, et cetera, et cetera. So, you know, you can pretty much always use DQL for the most common use cases. But if you have a very custom SQL query, or say you want to take advantage of some very specific feature of a relational database, you can always write a very specific, explicit SQL query and use the native query builder and then explicitly map the data returned by that SQL query to an entity that Doctrine knows about using the result set mapping class. And internally, Doctrine actually just uses the result set mapping. We're just internally populating that result set mapping automatically with all of the information that we know about the objects involved in the DQL query. So under the hood, it's doing the exact same thing. You're just doing it manually here instead of relying on the automatic features that the ORM provides. All right, so we have we can take about 5 or 10 minutes. If anyone has any questions, let me see. I think there's a way to allow people to talk in Zoom. If you're not comfortable talking in Zoom, you can either ask the question directly in Zoom, or if you're in the Slack chat, feel free to ask the question there. If anyone has any questions, just let me know. If not, then we'll call it a day. All right, Mariano, can you hear me?
I can hear you. I can hear you, John. So I was just writing my question, but I'll say it out loud. If the migration option is used, the changes shouldn't be made before in the database, or should also like options for safe, for safe database should be used, like create if not exist or things like that. Should those be considered?
Well, you really don't have to do that because, you know, the migration is never going to get executed twice because Doctrine keeps track of which migrations have been executed. So if you have a migration that creates a table and that migration tries to get executed again, then that's an indicator that the table that tracks the versions that have been executed is not synchronized with the actual database schema. So I don't think you would want to do create table if not exist, because otherwise you're kind of silencing a real problem. And so you'd actually want to see that error because it's indicating a real problem.
Now, quick question. Sorry, I don't know if anyone has another one. But in a perfect world scenario, let's say I got a project, I found on GitHub or something, and should the migrate command be run at the beginning, initially at the setup? Should the project include an schema set up somewhere else? I don't know if I missed that one.
Well, usually in the context of, your automated tests, in the case of MedTrainer where we work, it will create the initial schema, and then it will run all the migrations that have been added since that initial schema was created and bring the schema up to date with all of the versions that exist in source code. And then you would run that migrate command in all of your automation, in your deploy process, so that migrations, just when you deploy new code to production, it just automatically runs those migrations first. And that way, today, you have to run those SQL commands manually across all your different environments. If you have automatic deploys and migrations are hooked up to those deploys, then all a developer has to do is create a pull request, add a property to their entity, create a migration to alter the table to add that column for that property. And then when that code gets deployed to any environment, it will say what migrations have been executed already and which ones haven't. And it executes the up method on all of those and brings the database up to date with the code that's actually deployed to that environment. Does that make sense?
Okay. Yeah. Yeah. Thank you.
Yes. Any other questions?
I have another quick question.
Sure.
Is using the, when you were, I think there was a step in the presentation where you showed that, in kind of doing like a concat over a string of a parameter received on a request would lead for SQL injection. So does this mean that if we use Doctrine in the proper way, setting a property through a set parameter, should we be covered against SQL injection? Is that something that Doctrine automatically manages?
Yeah, those are called prepared statements, and it's not really a feature of Doctrine. It's actually a feature of PDO, and really any low-level way to communicate with a database supports that type of stuff. You always want to use parameters, and the reason why is because it protects you against SQL injections. If you're taking a value that a user inputs and concatenating it directly into a query, then the user is literally getting free access to write whatever SQL they want. And theoretically, they could alter the SQL query and pass a drop table statement. And all they have to do is like end the current query with a semicolon and start a new query with a truncate table call or a drop database or drop table.
Okay.
So there was a question, is it also possible to have DQL injection? How to prevent that? It's 100% the same as SQL. You just always want to use those parameter placeholders. So if we go back to right here, where is it? Right here. So this is a DQL query, and where we want to return user objects where username equals this parameter placeholder, and we pass the value to the first argument of the execute method. So underneath the hood, this is a prepared statement, and it's using parameters. So this query, if this value came from a user's input, there's no way that user could manipulate the SQL query and do something malicious. I think, here we go, Abraham Martinez. Okay, I think you should be able to talk now. You have to unmute yourself though. Here, I think I can unmute you maybe. No, I can't. There we go, you're unmuted now.
Okay. It's okay?
Yes.
Okay. So I have this quick question. For example, we have three tables, A, B, and C, right? So every table has an entity and a repository class, right? When I want to use some join logic, when I want to retrieve some logic from that three tables, where do I put that logic?
So if you're returning a user, I'm going to go ahead and mute you. So if you're returning say a user entity, and a user has phone numbers and addresses, and you join those phone numbers and those addresses, if it returns a root entity, you're going to want to put it in the repository of that root entity. So even though you may call user get phone numbers or user get addresses, on the user entities that are returned, you would still put it in the user repository. But say, for example, you fetch, multiple different objects from different repositories. Ideally, you would have the individual methods for each entity in the appropriate repository, but then there's a layer above that in between the controller and the Doctrine repositories, and that's your service layer. So an example would be, I'm struggling to think of a real world example, but you might have a service that's called, I don't know, user manager or something like that. And it would depend on the user repository. It would depend on the phone number repository and the address repository. And there would be a public method on the user manager that your application code in the controller would call. And it depends on those other repositories. And your controller should really do nothing. All the controller is like wiring and glue in between your different layers. And that way, your service layer and your repositories could be utilized across multiple controllers. Or, say you had a service for creating users, and users could be created multiple ways. A user could be created through an API. It could be created by running a command locally to parse a CSV file and create users for every row in the CSV file. And you could also just have a normal registration form that creates users. And even those are three different paths. Underneath the hood, it's going to call one service that is responsible for creating users in the system. And that way you only have one place internally that users are created, and you can test that code. If you didn't have that kind of service, then the controller, the API, the console command would duplicate that code over and over and over to create users in the system. And that can just lead to all kinds of problems, because you could have a bug in one area where a user joins and not a bug in the other area. So, for maintainability and just ease of understanding how things work, it's always good to have that service layer that kind of consolidates a lot of the rules and the logic. And some of that logic could even be put into the entities themselves for, the very simple logic, but the more complex things might be in the service layer. So someone, I think someone pasted a gist. Let me look at that. Okay, yeah, that's an example test. Yeah, that's cool. We do something similar to that so that it basically forces people to have to write a migration. Because if they introduce an entity and they don't have a migration for that entity, or they add a new column, this test basically fails. So that's a nice test. Any other questions? All right, well, I think that's going to be it for today. I'll be in the events channel in Slack as well if you want to ask any other follow-up questions or want to continue the conversation there. But I really appreciate everyone joining. Check in on the Doctrine website for future events. We actually have 3 or 4 other events scheduled for the next several months. There's actually one on unit testing that's coming up by Chris Hartjess. And then we have one on MongoDB. And then I think we have another one by Marco that's going to be coming as well. So thanks everyone for coming, and hope to see you again in the future. Bye.